All right, good day, everyone. Today we're going to be focusing on arithmetic sequences. Once again, we're going to go a little bit more in depth and start talking about the arithmetic series as well, and we're going to start deriving some of the equations that we're going to be using within this unit, okay? Just looking at our learning targets today, or a couple focuses are, we're going to be dealing with sigma notation. We're going to write algebraic form with a lot of these arithmetic sequences, as well as calculate the nth term of a partial sum, okay? So let's go ahead and get right into it. The very first thing we want to talk about in this whole section is, first off, a partial sum and what is sigma notation, okay? Sigma notation is a way for us to describe a partial sum of something. Honestly, it's used within our arithmetic series equation, and it kind of helps us describe what's happening within the problem, okay? First and foremost, understand that a sigma notation is basically this notation right here, okay? That little weird looking E stands for sigma notation, okay? This helps guide us in finding a partial sum, okay? To kind of help describe what a partial sum is, if you really think about it, patterns can kind of go on forever. If I said start at 1 and count by 2, that could just continue on forever, all right? That's never going to end. So when I say find the sum of all that, it's really not possible because it's a continuous problem. A partial sum basically says, if I want you to find the sum of the first 6 terms, you could do that, okay? So for example, if I had like 1, 2, 3, 4, 5, and that kept going on, you couldn't find the sum of that pattern because it's continuous. However, if I said find the sum of the first 5 numbers, this would be a partial sum of that total right there. 1 plus 2 plus 3 plus 4 plus 5, okay? I can't find the full sum of the whole pattern, but I can find a partial or piece of the sum within it, okay? So basically, this is how that kind of works, okay? A sigma notation, basically in this sense, is one of the forms of finding a sum of those values. So I kind of just have a couple of things written out. In letter A here, they have a j equals 1 on bottom, a 5 on top, and a p of j outside of the sigma symbol, okay? The big thing I want you to understand is that the bottom value, that j equals 1, is actually your starting value. That is the first number that we are going to plug in within our notation. The actual top value is where we end, okay? So the partial sum goes from 1 until we get to 5. The p of j is the actual equation itself. So if I were going to write this out, this would be p of 1, because that's our starting point, plus p of 2, plus p of 3, plus p of 4, plus p of 5. And eventually I would stop there because that is my ending value. So as you can see, really, the numbers on the top and bottom of the sigma kind of describe where I start and where I end, while the equation kind of just describes what am I plugging it into, okay? I plugged it in for j all the way up until I got to the value of 5, okay? So let's go ahead and apply this. If we scroll down, I believe to you it's on the next page, which is ended up being page 9. Let's just quickly talk about one of these because it is a pretty straightforward problem. Let's say I'm given this sigma notation here, j equals 1 on bottom, 4 on top of the sigma, and then our equation is 5j minus 1. Basically, to solve this out, what I'm going to do is I'm going to plug in the values of each of these. So I would start off, this would be 5 times 1 minus 1, okay? All I'm doing is plugging 1 in for j, plus 5 times 2 minus 1, okay? So I went up 1, plus 5 times 3 minus 1, plus 5 times 4 minus 1. Okay? So see, I'm just building up each time, all right? I started with a 1 as for j in the first portion until I counted up until I got the 4, which is our ending value. From there, all I have to do is just solve this out. Well, if I do this quickly, 5 times 1 minus 1 is just going to come out to be 4. This is 4 plus 5 times 2 minus 1 is going to be 9, plus 5 times 3 minus 1 is going to be 14. And last, 5 times 4 is 20, minus 1 is 19. Okay? So all I did was just solve out each of those pieces. And if I add those all up, I get a final answer of 46. So the partial sum of that equation from 1 to 4 comes out to be 46. Okay? And that's really all a sigma notation is. It's going to help describe to us, basically, if I take a pattern, if I want to know the sum of a certain portion of that pattern, where am I sitting at? Okay? Let's go ahead and just move on then. All right. A lot of this is a lot of the same material. You're welcome to kind of try these out if you want to actually work through it. Please note, like, for example, I think this one's the same exact problem. I believe so. And then the same thing here. Like, it's the same exact process. You would start at 0, you'd up until you get to 3, and then you would add those values together to find the sum. Okay? But let's just work on the bottom of that page. Let's jump to this little picture right here. Okay? This is kind of what we want to get into today. We want to talk about how do we derive a series equation? How do we find an arithmetic series without actually having to use sigma? Okay? To do this, we are going to derive it out. But to do this, we kind of have to start off with this basic picture here. And it kind of relates back to our DVD problem from the last episode, or the last video that we had. Basically, what this is asking for is the figure figure 1 represents the given number of DVDs rented from Fantastic Flicks, the total number of DVD points from those rentals, how many rentals are represented in this figure, and how many DVD points have been accumulated over the rentals, okay? So if you remember talking about it the other day, the actual number of rentals, okay, that's the actual pattern itself. That's basically saying how many DVDs have we rented. To actually find this, all we have to do is just count the total number of squares that are below here, or basically how far over do we go. So we have 1, 2, 3, 4, 5, 6. Okay, you see how I went over 6 boxes? That means that is our DVD rentals for that week. Okay, if I go up, this is how many points they received at each of those DVD rentals. Okay, so to kind of just label this out for us, this is the points, and this is the rentals. Okay, so in this case, if I counted below, I was 6 total rentals. And then to find the number of accumulated points, based on the last video, we talked about how to find the total points, we count the area. So we would total up all those boxes, and just to kind of make this a little faster for us, that would come out to be 48. Okay, we have 6 rentals, and that would give us 48 points. You can go ahead and turn the page, and we're going to start to discuss these next couple of representations. The next thing we want to talk about is basically how can we help derive this into something that we know, okay? First and foremost, we want to talk about how does this figure represent, or what is this figure representing, okay? Well, if you really look at this whole figure, right, there's 2 things I notice. The actual box itself is a rectangle, right? So if I think about the actual box itself, we have a rectangle, okay? And if you really think about this figure, right, I know it's not perfect, but it's pretty similar to that of like a triangle, right? If I just connected this line and kind of went over, yes, I have this little portion here, but if it continued down all the way to the 0 point, I would build a sort of like a right triangle, right? If this continued past this portion here and this continued down on this line, I would create this triangle-like figure, okay? Excuse me, that drawing was terrible. I get it. Trying here. But we basically build this triangle, this rectangle and triangle figure. Okay, and that's going to be important to actually while we derive this equation. Okay, I want you to think about those 2 values. So the next portion we want to talk about is how do we actually derive stuff based off of this? And the first thing we have to do is understand they're giving us this equation right here out of this form. Okay, and they want us to basically understand, like, where are they getting the first and last term, the j of 1 and the 6 on top, or what are those first and last term equal to? Well, the j equals 1 is referring to that p of 1 value, which, if you remember, 1 DVD rental is going to give us 3 points. Okay? The 6 on top is that final value. So after 6 rentals, how many points are we going to have? Well, this kind of goes back to the other chart that we did yesterday. At 6 rentals, we would end up with 13 points. Okay? On our 6th rental, we would receive 13 points. Okay? So now what we have to do is try to think. Okay, letter D is asking us to find the area of the rectangle in terms of 6p, p of 1 and 6, and p of 6, excuse me. To do this, we have to understand what a rectangle is. Okay, now, first and foremost, the one thing I want to bring back is, since they're talking about area, The area of a rectangle is base times height, right? Base times height. In this case, we got to talk about what each of those represent. Well, the base of this figure is easy, okay? The base of this figure is actually pretty easy, all right? It just goes over by 6 units, okay? So our base equals 6. The next portion that we have to understand is that these two figures are related. And to actually find the true length of the rectangle, I need to combine these two together. So these would overlap. So what I need to do to find the height is I have to take my P of 1 and add it to the P of 6. Okay? It's the height of my lowest point plus the height of my highest point, which gives me the total height of that rectangle. Okay? Well, now I can develop a problem or formula based off of that, okay? If I plug those two in, isn't this really just going to come out to be 6 times P of 1 plus P of 6, right? So now, what they want me to do in letter E is find the area of the two regions, okay? And this kind of brings in the second portion. This would be the area of the rectangle, correct? Base times height off of that problem. However, the actual picture of itself is technically a triangle, right? So if we think back to that, isn't it just a triangle half of a rectangle, 1/2 base times height? So if I want to find the area of this value, all I have to do is take the original equation, which is right here, the area of a rectangle, and to turn that into a triangle, I just have to take 1/2, so 6 divided by 2, times P of 1 plus P of 6. And I've developed that area to find that portion. And if you really want to test out the math here to see if it's right, well, let's try it. This would come out to be 3, 6 divided by 2, times 3 plus 13. And if you work that out, you end up getting an answer of 48. Oops. Move my face out of the way, blocking my 8. 48. Okay? So what we're doing is we're using the same idea in that the area becomes the total sum of all these values. Okay? But now we're trying to compare our geometry with that. To find the area of this, I have to think of this as being a triangle. Well, then I can develop a formula down here using that. Well, a triangle is 1/2 base, which is 6, times the total height, which is P of 1 plus P of 6. And using that, I can almost find the actual answer. With that information, I basically can create a formula here. Okay? This here is our series formula, or I always note this as S of n. The series or the sum of the total. The n represents the term that we're on. P of 1 is the first term in the problem, and obviously the divided by 2 is that whole idea of a triangle. From there, I kind of have this chart filled out for you. I didn't feel the time to really waste a bunch of time just trying to solve this out. But if you notice, we can actually solve out any type of series with this equation, okay? If I want to figure out how many total points I have at one DVD rental, all right, I would have the total points I start with, and then this is your actual answer of your sum, and this is the formula itself. 1/2 of 3 plus 3 is going to equal 3. At 2 DVD rentals, I'd be earning 5 more points. I would plug it into the equation. 2 divided by 2 is 1. 3 plus 5 would be 8, and that would give me my total points. So see how each time it actually works out in giving me the total points, okay? So for example, we talked about how at 6 DVD rentals, I should have 48 points. Well, if I do that same process, this would be 6 divided by 2, because we had 6 DVD rentals. I always started with 3 points. At 6 DVD rentals, I would have 13 points, so P of 6 is 13. And I would go ahead and solve that out to get an answer of 48. Okay? Once again, we kind of can go through that in a little bit more in depth moving forward. That's just kind of the idea of a partial sum, okay? You can go ahead and finish off the rest of this if you like. That was the main concept of today's lesson, starting off and trying to find the series of a certain value, okay? Go ahead and finish off by answering all the questions, and if you have any questions, bring them to class tomorrow, and we'll talk about all of this. Besides that, have a great day.